Alright, hello 8th grade math students. In this video we are going to do the Module 5 review. So this is everything that we've done from second semester and also the last week before we went on winter break. So for number 1, it says the data in the table does or does not represent a function. So for this one we are just simply trying to see if there's a pattern for the x's and the y's. This one is plus 1, plus 1, plus 1, plus 1. As you notice, there is a pattern, so we're good with the x's. For the y's, it goes minus 3, minus 1, plus 1, plus 3. And for that reason and that reason alone, there is no pattern on the y's. If it was minus 3, minus 3, minus 3, minus 3, then we would say that it's a function. But because it's minus 3, minus 1, plus 3, that means that this one is not. So the data in the table do not represent a function. For number 2, you'll notice that we gave you guys 4 different types of graphs, right? So for number 2, it says indicate whether or not each graph represents a function by placing an x under. So there's 2 ways that you can do this. Right before we went off winter break, I taught my students about the vertical line test using your pencil to go across from left to right. As long as it only hits it in one spot, then it's a function. If it hits it in more than one spot, then it's not a function. Now, seeing that you guys are not able to see my pencil because my iPad won't allow that, all I'm going to do is I'm going to simply draw lines going straight down. Okay? Vertical lines going straight down. You'll notice that it only hits once. It only hits it once. If it only hits it once, then that is considered a function. If it hits it more than once, give you an example, okay? When I draw a line going straight down, it hits it here, it hits it here, it hits it in more than one spot, which means that it is not a function, okay? Same thing. If I draw lines going straight down, imitating a pencil, you'll notice that it hits it in more than one spot. That means it is not a function. If I go to the last one, it only hits it in one spot. It only hits it in one spot. It only hits it in one spot as I draw a line going vertically, which means up and down. So because of that, the only ones that are functions are the first and the last graph. All right, for question number 3, it says, Adrian needs to repair his motorcycle. There are 2 mechanics in his hometown. The prices for mechanic A and mechanic B are shown, where X is the number of hours and Y is the cost. So if we go for the first one, mechanic A, they only give us a equation, and that's fine because they're telling us that they're going to work on Adrian's bike for 10 hours. So for mechanic A, we just do 25 times 10 because X is the number of hours. And if they work on it for 10 hours at $25 an hour, they're going to charge Adrian $250 plus the additional $100. Now, my first period asks, what is the extra $100? It could be like the cost of parts, for example, right? So if maybe he needed a belt that needed to be replaced, that's the cost of extra material. So $250 plus $100, that means that this mechanic A, is going to charge him a total of $350, right? For mechanic B, right, it tells you that when it is X, okay, so when they are working on it for 10 hours, okay, you'll notice they are going to charge Adrian a total of $300 by just simply looking at the table because it was already given for us. So for mechanic B, they're going to charge us $300, okay? Now, obviously, when you go to mechanic, you want to pay less money. You never want to pay more money. So then part A says, which mechanic charges less for a 10-hour repair? So you would say mechanic B charges less because $300 is less than $350. All right, so for question number 4, they simply want us to fill out the rest of the table using the equation, okay? So a few things that I want to note, right? So this is the same, when you see f of x, that's the same thing as y equals, okay? And then because it has negative x, that's the same thing as negative 1 times x minus 7, okay? First period kind of had a little bit of a tough time, and I had to remind them that whenever you have a letter in the alphabet, also known as an unknown variable, and it doesn't have a number in front of it, there's an imaginary 1. So that's why it's a negative 1 in front, right? So very simple. Here's all we're doing. We are simply putting in the value for x. So to start, we plug in a negative 1. So you do negative 1 times negative 9 minus 7. So negative 1 times negative 9 is a positive 9. 9 take away 7 gives you 2. The next one is simply negative 1. The second value of x is a negative 3. So you'll notice that all I'm doing is I'm just plugging in the value of x into the equation. So negative 1 times negative 3 is a positive 3. Positive 3 take away 7 is a negative 4. And then I continue doing this for the rest of them. I like to streamline it, and I just like to put them all at once, and then I go back and then I fill it in. So for when x is 1, negative 1 times 1 is a negative 1, and then negative 1 minus 7 gives you a negative 8. And then the last one, negative 1 times 7 is a negative 7. Negative 7 minus 7 is a negative 14. For number 5, the cost of stamps depends on the number of stamps purchased. The total cost, y, for x stamps is represented by the equation y equals 0.49x. Graph the function using a function table. So they want us to make a table, so off to the right over here, make a table, right? Just like I said before we went on break, you choose any numbers you want. I always start with the number 0, and then I'm going to do 0, 1, 2, 3, and 4. Okay? So this is probably where some of you guys are going to need your calculators. Okay? So if we start with 0, okay, if you buy 0 stamps at 49 cents a stamp, what's 0 times 49? Well, that's just simply 0. So my first point is going to be down here where it says 0, 0. We said that every stamp costs 49 cents. How do I know that? Because in the equation it says y equals 0.49x. The 49 just simply means 49 cents per stamp. So 1 times 49 cents, 49. 2 times 49 cents, and again, I'm just using my calculator here. 49 cents times 2, this gives me 98 cents. 3 times 49 cents, 3 times 0.49, gives me $1.47. And if I decide to buy 4 stamps at 49 cents, that will cost me $3. Oh wait, let me double check that. 49 cents times 4 cost me $1.96. So you'll notice here, one stamp is 49 cents, right? The first thing I asked first period to do is, you'll notice that it goes 0 on the left side, and then 0.98. So then I told them, what's half of 98 cents? And they were like, oh, that's just 49 cents. So one stamp costs 49 cents. We said 2 stamps cost 98 cents according to my table. 3 stamps cost $1.47. This one happens to be $1.47. And if you haven't figured it out already, the pattern is it's just going on the corner of every single square. So if you just take your ruler that I told you all to get, and if you connect all of those, you'll notice that every single stamp is going up by the same constant rate, because it's just simply 49 cents per stamp. A caterer charges $150 plus $15 per person served. The total cost is represented by the function y equals 15x plus 150, where y is the total cost and x is the number of guests. If Tatiana invites 200 people, call it a quinceañera, for example, how much will it cost? So we are simply going to use the equation. The equation we said is y equals 15x plus 150. The x is the one that represents how many people are going to be served. So Tatiana is going to be paying to have 200 people served. Okay? So first thing you do on your calculator, 15 times 200, that is $3,000. And then if you do 3,000 plus the 150, that means that it is $3,150. So most quinceañeras or most even weddings will typically charge per plate. $15 is kind of on the cheaper side, especially if you are getting married at a very nice venue. They will typically charge you about $30 per plate. Number 7, write the equation that best describes the linear relationship shown in the function table. So we are going to need to write it in y equals mx plus b form. We need to find the m, we need to find the b. So how do you find the m? Remember that the m is the change in y over the change in x. How do you find the b? When x is 0, the y value is your b. So we're going to need to find both of those in order to create this equation. So first let's start with the m, which is the slope, right? The slope is the change in y over the change in x. These are all changing by 11. These are all changing by 1s. So if you do 11 divided by 1, then your rate of change is simply 11. Okay? And in order to find the b, which is the starting value, you need to work backwards, right? So 2 take away 1 is 1. 1 take away 1 gives you 0. And then for your y's, it was going up by 11. So the opposite of going up by 11 is to go down by 11. So if you take 11 and you take away 11, you get 0. So when x is 0, the y value is also 0. So now that we have our information, we can write our equation. So the equation would simply be y equals 11x. Or you can write y equals 11x plus 0. Most textbooks will not put plus 0. They will just leave it out, which is why some of you guys are always like, why does it not have a number in the back? So for number 8, it says, Shirley has already jogged 5 miles. She continues to jog an average of 3.5 miles per hour. This situation is modeled by the function y equals 3.5x plus 5, where y is the total number of miles jogged and x is the number of hours Shirley continues to jog. So this one's fairly simple. Identify the rate of change and identify the initial value. So the rate of change is how many miles she is running per hour. We've already established that that is simply 3.5. So every single hour, she's able to run 3.5 miles. Okay? And then the initial value is how many miles she's already ran. She's already ran a total of 5 miles. So that's our initial value. Boom, you're done. You don't need to do anything else. For number 9, it says Marley is racing her older brother. Marley gets a 20-meter head start. Use a graph to find Marley's speed. Then write a function in slope-intercept form that shows Marley's distance in y based on how long she has been running for x. So again, we need to put this in y equals mx plus b form. The m in this case is going to be the rise over the run. The b is going to be the y-intercept. It's the initial value, right? So first, let's figure out the rise and the run. You have to choose 2 points. And some of you guys are going to say, but Mr. Gutierrez, there's only 1 point up there. Where's the other point, right? The other point is down here, okay, where the line hits the corner of the box. So now we have 2 points, right? So if we are going from 20 and we are going up, it goes 10, 20, 30. These are each going up by 10, which means this is going up by 30. That's your rise. And then the run, okay, is the x value. And your x values are only going up by 1. So this is 1, 2, 3, 4, 5. So this one's the 5. And then 30 divided by 5 is simply 6. That means that Marley is able to run 6 meters per second. Okay? And then the y-intercept is her starting value. It's what head start her older brother is giving her. Well, her older brother is giving her a 20 meters head start. So the b, or the y-intercept, is simply 20. And then when we write our equation, it's simply y equals mx plus b. So the m we said is a 6, the x stays, and then the starting value, how much she got a head start, is simply 20. For number 10, determine whether the mapping diagrams or functions justify your answer. Okay? So, parents, I apologize in advance. This is how I taught it to the kids. Input are the girls. Output are the boys, right? So, before we went on winter break, right, our society says that guys can have multiple girlfriends, but girls can only have one, right? So, as long as the input, which is the girls, only have one output, which is a boy, right, then it's okay. So if you notice, number 4, right, think of any name you want, is dating number 2, right? So one girl is dating one guy. That's perfectly fine. Number 5, one girl is dating one guy. You'll notice that 8 and 9, think of any names of girls that you want, they are both dating number 11. So the guy has 2 girlfriends, right? That is okay. That is considered a function. So for number 10, the first one is considered a function, so this one is good. That is a function. I'll put F for function. If you notice the second example that we gave you, right? The input, the 2 is the girl, the 4 is the boy. That's fine. But look, number 7, that's a girl. She's dating 2 boys. That's a no-no. You cannot do that. I know some of you guys are upset about that, but that's just the way it is. So because 7 is dating number 5 and number 8, that is no bueno. So this is not a function. Okay, number 11 is pretty much the same. The only difference is their coordinate points instead of the actual diagrams, but it's all the same thing. So -1, right, is just a girl who's dating number 4. 0 is dating 6. 0 is also dating 8. And because there is the same input dating 2 different outputs, that is a no-no. So this one is not a function, because each input should have its own output. So 0 is not okay. For number 12, indicate whether each graph represents a linear function or nonlinear function. Linear means it's a straight line. Nonlinear means it has curves. So number 12, definitely linear. The second one, non-linear. The third graph, non-linear. And then the fourth one, linear. You are just simply taking a look at if it is a straight line or not. Straight line, linear. Non-straight line, non-function. Or non-linear function. Number 13, the graph of a linear function is a straight line. So the answer for that one is letter D. For number 14, the graph represents Tom's distance from home while on a bike. Okay? Describe how the distance from home changes as time increases. Okay? So, as Tom is riding his bike, you'll notice as time goes on, time meaning that it goes to the right, the longer the time, the longer the distance he is from home. And that kind of makes sense, because if you're riding a bike and you're just riding going east or west, whatever direction, the further you're going out, the further away from home you are, right? So it says describe how the distance as home changes. So we just say, as Tom rides his bike, he is getting further from home. The only reason why it's curved is because the longer he rides, the slower he gets, because he's running out of energy. Okay? Oops. Alright, for number 15, there's 3 parts. There's 3 graphs, there's 3 scenarios. You just simply have to match each scenario, right? So let's start with the first one. Sandy walked home at a constant rate from the store. Okay? So she's at the store and she's walking a constant rate back home. The only one this one can be is letter C. Okay, so she's away from home, she's at the store, and then she's just simply walking back home, which is why it's a constant rate, a line just going straight down. I'm going to eliminate that one just so we don't try using it again. The second one, Sandy jogged from her home to the bus, right? So you'll notice both of them are starting at the bottom, which means she's starting from home. She jogged from her home to the bus stop at a constant rate. She stopped to wait for the bus. Sandy realized she had missed the bus, so she walked home at a constant rate. Okay? So, essentially this one, right? The one where it says she's going to the bus stop, she's jogging, which means that it's going faster. Okay? The only one that tells you that it's going faster is graph A, because you'll notice that the slope of the line is higher than the slope of this line. Okay? So when you're jogging, you're obviously jogging faster. It's going to be straight up even further. And then, of course, if you're sprinting, then her line would be something like that, because she's running at a lot faster rate. So that means that graph A goes with this one. That means that graph B has to go with that one, because we've already eliminated the other 2. All right, for number 16, Lynn started to walk to class at a varied rate. Lynn realized she forgot a notebook, so then she walked back to her locker at a varied rate. Then Lynn walked to class at a constant rate. Sketch a graph to represent the situation, right? So the bottom part, we are going to label time, okay? So she's walking, so we can either say minutes or seconds. It really doesn't matter. It's just the time, okay? And then for the y value, right, it's she started to walk to class, so we could say distance away from class, or we can even say distance to the locker. It doesn't really matter. So we're going to say distance. That's hard to write as I'm writing on my iPad going upwards, right? So it said Lynn started to walk to class at a varied rate. Varied, it's not constant, which means it's going to be curved, right? So when you are walking, you're not sprinting, right? She's walking at different paces. It doesn't matter if it's this way. It doesn't matter if it's this way, right? So maybe she's walking slow, and then she sees her friend, so she starts walking a little faster. And then she realizes that she forgot her notebook, so she walked back to her locker at a varied rate. So she's starting to walk back to her locker at a varied rate. Then Lynn quickly walked to class at a constant rate. So at a constant rate meaning that at a constant rate she started to walk faster. So it looks something like that. For number 17, determine whether the function is linear or nonlinear. In part of your notes for if something is linear or not linear, I said that as soon as you see an exponent, it is automatically not a function or a nonlinear. So this one is nonlinear because exponents make it curved. Oops, reconnecting. Make it curved. And then last but not least, write an equation. This is the stuff that we just did this last week. This is your x, this is your y. This is your x, this is your y. These are going to be 1s. These are going to be 2s. So first step, we need to find the slope. In order to find slope, it's y2 minus y1 over x2 minus x1. So if I plug in what I know, this is 5 take away 1 over 3 take away 1. That gives me a 4 over 2, which gives me a 2. So that means that my slope is a 2. That's the first piece to it. That's not the final answer. Then I take any point I want. It really doesn't matter which one. So my y is my 1. My x is my 1. All I did was I chose this first set of points. And then my m, which we just found, is a 2. So using that information, I have to now find the letter b. Remember, to find b, it's y equals mx plus b. I plug in everything that I know. This is a 1, this is a 2, this is a 1. We're trying to find the b. So if we try to find the b, right, what number plus 2 gives me a 1? The b would have to be a negative 1 in order for that to work. I just found the second piece to that. Now that I have the m, now that I have the b, I write my final equation, which is always in y equals mx plus b form. So y equals 2x. You could put plus negative 1, or you could just put minus 1, however you want to do that. So that's your final answer. So please, ladies and gentlemen, please make sure you study. Please make sure you watch this video as many times as you need to in order for you to comprehend what's going on. There are no makeups. This is a unit test, so please study your little butts off tonight. And we will see you guys tomorrow. The test will be Tuesday and Wednesday. Adios, people.